Chapter 4, Section 5, Solving Polynomial Equations. We're going to put everything we've learned together with adding, subtracting, multiplying, factoring especially, and dividing especially in order to solve polynomials. We're going to figure out what the x's are. Remember, when we're looking for solutions, solve zeros, x's, intercepts, factors, all of those mean the same thing. And what that is where this crosses the x-axis on the graph. First way we're going to look at solving these is, like they say here, by factoring. If it's factorable, should be the quickest, easiest way to do it is to factor it, possibly. We're going to look at another way that's even faster for most of the answers, but we still might have to do some math to get all of the answers. But let's look at solve 2x to the third minus 12x squared plus 18x equals 0. Once it's set equal to 0, that's when we know we're in the solve mode. Okay, so we are going to use that zero product property. If we factor this thing all the way out to this multiplies times this multiplies times this to equal 0, if any one of those is 0, then the whole thing's 0. That's why we're looking for what's called zeros. Answers, x's, solutions, solves, intercepts. So let's greatest common factor first. They all have a 2 and they all have an x, which leaves me x squared minus 6x plus 9 equals 0. And I notice that it's a perfect square trinomial, but just in case you don't see it, we can do it the old-fashioned way. It's going to be 2 parentheses. Factors of 9 that add to 6, each one gets an x. Each one's going to get a 3 because 3 times 3 is 9 and 3 plus 3 is 6, and we need them to be negative so it matches the negative 6 in the middle. So that means that 2x times x minus 3 times x minus 3 equals 0. So if any one of those is set equal to 0, they'll give us a solution. So we do 2x equals 0, and we divide by 2, and we find out x equals 0. That's answer number 1. So x equals 0. We've got x minus 3 equals 0. Add it to both sides, so now x is 3. Opposite to get out is the quick move for that. And x minus 3 is exactly what we just did, so when we do it again, we still get x equals 3. So we get x equals 0, 3, and 3. And I'm fine if you circle the answer right there. The book will probably just say x equals 0 and 3. We know it's supposed to have 3 answers because the degree of the polynomial is 3. So if they only list 2, it's either a repeat or they forgot one. Okay, so you just don't know which one is the repeat here with the 0 and the 3. If you list both, you know it's the 3. That's all it takes. Factor it out, set them equal to 0. Anything that is like the 2x, multiplying, all of that kind of stuff, it's going to be 0. It's got to have an add or a subtract in there with it if it's going to not be 0. In example 1, the factor x minus 3 appears more than once. We just talked about that. This creates a repeated solution of x equals 3. Note that the graph of the related function touches the x-axis but does not cross the x-axis at the repeated 0, x equals 3, and crosses the x-axis at the 0, x equals 0. So let's look at what they're saying there. We go back and we actually graph this, and this is going to lead us into our shortcut that we're going to do. We do 2x to the third. Minus 12x squared plus 18x. And we look at where it crosses the x-axis. It crosses all the way through at 0, 0. That's the one place it crosses. And then it's almost like it touches twice at the 3. It touches when the arm is coming down on the graph and then when it's going back up on the graph. So it touches in three spots, kind of. Okay, it hits the 0, 0, it hits the 3, 0 twice, coming and going. So it gives you three answers. Okay, so they got a little rule about that there. If it's just kissing the graph, it's a twicer. If it crosses the graph, it's a oncer. Okay, so finding the zeros of a polynomial function, and well, actually, let me go back. What another thing they might say, if they say if you have a factor to an odd power, the graph crosses the x-axis at x minus k. So if you have like x minus k to the first or x minus k to the third, it's going to cross multiple times. If it's an even power, so it's like it's x minus k squared, or you might say x minus k to the fourth, that's going to just touch the graph at the x-axis. Find the zeros, then sketch the graph. We're not going to do the sketch the graph because we haven't really been graphing that much. We're going to use the graph. So we're going to use Desmos really big to find the answers that we need. We're going to need some things though. We need to know the degree. We need to know how many answers there should be. We should have 4 answers. So x is going to equal 1, 2, 3, 4 things. We're going to write all of them in those blanks right there. If it's factorable, you should do that first. That would kind of be the easiest way to do this. They don't all have an x, but they do all have a 2, a negative 2 even. So I'm going to pull a negative 2 out of there. And that leaves me with x to the fourth minus 8x squared plus 16. Now this is one that's not really a quadratic, but we could factor it like a quadratic. And we could say that that's really x squared squared and use that quadratic form. And say the x squared is just one whole thing. So this is going to get an x squared and that's going to get an x squared. And then factors of 16 that add to 8 are 4 and 4, and they're both negative. Now if we keep looking at those, if we do our discount double check, x squared minus 4, that's a difference of squares. So it's going to break up, and both of them are x minus 4, so it's going to be difference of squares. So we're going to get an x plus 2 and an x minus 2 and an x plus 2 and an x minus 2. And so it should, when we put in our x's, right, opposite to get out, the negative 2 out on the outside doesn't really do anything. In fact, when we're equal to 0, we can even just divide that whole thing off and it just goes away and we just have our parentheses, right? I forgot we're equal to 0 here. But we have an x plus 2, opposite to get out is negative 2. We have an x minus 2, opposite to get out is positive 2. X plus 2, opposite to get out minus 2. X minus 2, opposite to get out is plus 2. So we got negative 2 twice and 2 twice. So that tells me it touches the graph in those places. So if we were to sketch it, which we don't really have to, we do know that when x is negative 2 and when x is positive 2, it's going to just kiss the graph. If we look back at our original, it's negative leading coefficient, so that means it points down on the ends, so we know it goes down this way some way. So most likely it comes up here, does this. It does cross the y-axis at negative 32. This is my y-intercept. So somewhere way down here, so it's going to go, and it's going to come back, and it's going to go, and it's going to go like that. So if we look at the graph of it, let's just graph it. Negative 2x to the fourth plus 16x squared minus 32. Okay, so there's my 2 places where it touches, and you can see that W that it makes, and it crosses at negative 32 down there. So our y-intercept's back here at the back. The constant's always our y-intercept, okay? That quote-unquote B that we had back in linear graphing. We haven't covered this much, but it's about the same thing as a linear graph. The degree tells you how many answers there are. If you take one away from the degree, that's how many bends there's going to be. So if you notice, we've got one bend up here at negative 2. We got a bend down here at negative 32, the y-intercept, and we got a bend over here at 2. That's 3 bends. Okay, degree of 4 answers, going to have 3 bends in it. And it points down. Has to because the leading coefficient's negative. Okay, we're going to use that to our advantage. We're going to start graphing these in Desmos and pull all the easy answers of these out. And then any of the weird answers, the irrational ones that have a radical in them, or the imaginary ones that don't show up, don't cross, we'll have to actually use our dividing skills and help factor in order to solve these. Okay, but we're going to do them kind of cheater style here. Let's pull Desmos back up here. So let's look. 4x to the fourth minus 40x squared plus 36 Boom, 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 boom. So x equals -3, -1, 1, and +3. That means that for number 1, I had x plus 3 times x plus 1 times x minus 1 times x minus 3. Those were all of my normal factors. If you don't have Desmos with you and you had to actually factor the whole thing apart, I would say that they all had a factor of 4 that I could divide away. Leaves me x to the 4th minus 10x plus 9 equals 0. And if I divide the 4 away, I don't have to worry about that. It's just a 0. So x to the 4th minus 10x plus 9 equals 0. And we factor these apart. Each one gets an x squared. How did I know it's an x squared? Well, that is a single, so that means x squared squared is my squared term. And factors of 9 that add to 10 are 1 and 9, and they're both negative. And there's our difference of squares, so it's x plus 1 times x minus 1, and x plus 3 times x minus 3. That's the factory way, and then you get x is -3 and -1 and 1 and 3. But we can graph them and do it so much easier. 2x to the 5th plus 24x equals 14x to the 3rd. We do need to get it all onto one side equals to 0. So we're going to subtract 14x to the 3rd on both sides. So we've got 2x to the 5th minus 14x to the 3rd plus 24x equals 0. Now, why are they in that order? Well, because 5 is bigger than 3, which is bigger than 1. I want them in descending degree order, standard form. Okay, so let's pull that graph back out here, and we're going to go 2x to the 5th minus 14x to the 3rd plus 24x, and we're going to zoom in here. Boom, bump, bump. 2. All right, so we got some weird ones in here that are rounding like this, okay? Those 3 decimal places is not a stop. Those are going to be irrational spots. So we've got 0 as one of them, 2 and -2, and then we've got 1.732 and -1.732. So this is what this looks like if we do it by hand, okay? I can take a 2x out of all of them. There's that 0 one, right? So x is supposed to equal 0. And let's bring that back out real quick. Oops, undo. Perfect. 2 and -2, right? Yep. 0, 2, -2, and then something else. That something else is going to be the one that we need to deal with at the end here. So if I pull out the -2x, I get x to the 4th minus 7x squared minus 12 equals 0. And that means we get 2x, and we're going to break this apart. And that's my whole thing, so x squared squared. So each one gets an x squared. And then factors of 12 that subtract to 7. Let's see, factors of 12 that subtract to 7. Oop, do I have the signs right? Nope. Add to 7. There we go. 3 and 4. That's why. Both have to be negative. Okay, so 2x times x squared minus 3 times x and x plus minus 2 and 2. So this one is the one that goes 0. This one, opposite to get out, goes -2. This one, opposite to get out, goes 2. Those are the 3 that were easy to see. And then this last one, x squared minus 3, we set it equal to 0 and we solve. We're going to add 3 to both sides. So we get x squared equals 3, and then we're going to square root. Remember, when we square root to solve, plus or minus square root of 3. So we're going to say plus the square root of 3 minus the square root of 3. 1, 2, 3, 4, 5 answers. Degree of 5 has to be the case. Now, the other thing we can check is we've got those decimal places on there. What is the square root of 3. 1.732, and it keeps going irrationally. See how they round that off. If you see those 3 decimal places, most likely it's been rounded off and it's not your exact answer. It'll work on a multiple choice test, but it won't work when you're solving the problem for the actual proper right answer. You're going to have to factor it down to where you can take that quadratic piece, set it equal to 0, and solve. Or take a quadratic that doesn't factor and stick it in the quadratic formula and solve that down as far as you can go. Okay. So now that you've seen some trickier ones, go ahead and pause the video, try number 3 and number 4, come back, and then see how 3 and 4 go. Don't forget to use Desmos for the easy parts. All right, let's look at number 3. Let's go easy first. 3x to the 4th minus 6x squared plus 3. All right, boom, boom. Hits in 2 places. X equals -1 and 1. Now, my degree is a 4. I should have 4 answers, but remember, because these are bending around there at that x-axis, that means that they're actually hitting that twice. So it's -1 twice and it's 1 twice, so that's all 4 answers that I need right there. Now let's go on to the next one. X to the 3rd plus x squared minus 6x, and we got 1, 2, 3. X equals -3, 0, and 2. We should have 3 answers, and we do. Bippity boppity boo. We are done. Rational root theorem. Okay. If you're solving these by hand and you don't have the Desmos calculator, this thing comes in handy. What the rational root theorem says is that there is a correlation between the factors of the first term and the factors of the last term and the answers that are there. Okay. So like this one is saying that 64x to the 3rd plus 152x squared minus 62x minus 105. The answers are -5 halves, -3 fourths, and 7/8. And we're going to get into that where we're going to have fractions. If you know the fraction equivalent to the decimal, like -2 halves would be -2 1/2 or -2.5. -3 fourths would be -0.75. And 7/8 is, let's see, 1,000 minus 100 is 900 minus 25, so it's 875, 0.875. Okay. But if you don't know those, you might have to use this rational root theorem to get you a head start in what numbers you can actually use. So here's what happens. The numerators, 5, 3, and 7, are factors of a -105. 2, 4, and 8 are factors of 64. So what it is that all of the possible combinations of the factors of -105 divided by all of the possible combinations of 64, and actually it doesn't matter if it's negative or positive, it's plus and minus both versions, gives you all of the possible solutions that could be one of your factors. So let's look at what that looks like. Okay, finding all the real solutions of x to the 3rd minus 8x squared plus 11x plus 20. This doesn't factor. You could try to group it and pull out the x squared, but there's nothing to pull out of the 11 and 20 to get you x minus 8 left over. So you can take the coefficient in the front, the 1, and the constant in the back. Factors of 20 are going to go on top. So 20 is 1 times 20 and 2 times 10, and not 3, but 4 times 5, and that's all of them. And the factors of 1, those are the easy ones, is 1. So you get 1 divided by 1, you get 2 divided by 1, you get 4 divided by 1, you get 5 divided by 1, you get 10 divided by 1, you get 20 divided by 1. And these are all plus or minus every choice. Which means that our choices are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. If we didn't have Desmos, we could actually do the synthetic divide on these and find out which ones give us a remainder of 0, bringing in that factor theorem we just worked on. And we can figure out which ones are the actual roots to the equation. But we have handy-dandy trusty Desmos, so we're going to go x to the third minus 8x squared plus 11x plus 20, and we go bip, bap, boop, and we know that it's -1, +5, and +4. Right, so not you, not you, not you. Not the negative, not the negative, not the positive. -1, 4, and 5 are our solutions equals. And 1, 4, 5. We will get to problems where we have to show the work because, like that one where we had to do the quadratic, we will get to that. Now, if it's not a 1, it's crappy because you got all of the combinations of 12, right? So you got 1 and 12 and 2 and 6 and 3 and 4. And then you've also got all the combinations of 10, which is 1 and 10 and 2 and 5. Which means you've got 1 divided by 1 and 1 divided by 2 and 1 divided by 5 and 1 divided by 10. And those are all plus minus. And then you've got 2 divided by 1 and 2 divided by 2 and 2 divided by 5 and 2 divided by 10. And then you got 3 divided by 1 and 3 divided by 2 and 3 divided by 5 and 3 divided by 10 and 4 divided by 1 and 4 divided by 2 and 4 divided by 5, 4 divided by 10, and 6 divided by 1, and 6 divided by 2, and 6 divided by 5, and 6 divided by 10, and 12 divided by 1, that's just negative, and 12 divided by 2, and 12 divided by 5, and 12, oh, that's weird. 12 divided by 10. These are all your possible combinations when you do that rational root theorem. Thus, the reason that we're using the graphing calculator. So let's look. 10x to the fourth minus 11x to the third minus 42x squared plus 7x plus 12. Now, to the fourth, there are 4 solutions. They're all decimal places. Okay? Some of them aren't that bad because 0.6 is 6 over 10. So that's one of them. Negative 0.5 is negative 1/2. The others are the trouble spots. We're not really sure how to do those as fractions. Now, what's nice is... Nope, not that one. Not that one. That one. Negative 1.562 and 2.562. It looks like we're adding and subtracting the same amount here. So, we can use these ones that we have, and then we can also use ones that are, we know, positive or negative, and we can look for that fraction that's going to be there. This is a 1. That's a 0.5. We already have that answer, so we know it's not those. 1/5. Let's see, just in case we don't know. 1/5 is 0.2, so it ain't that one. Let's see, 1/10 is 0.1. It ain't that one. That's a 2. That's a 1. How about 2/5? 2 divided by 5. Oh, clear. Undo, because I don't want that. Undo. 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 Okay, go to the end. There's our things back. And so let's go 2/5 is 0.4. 2/10, 0.2. 3 is not it. That's a 1.5. All right, so let's look at 3/5 is our 0.6, which is the same thing as 6/10. So if we shrink that down, that would be better. So we want 3/5. Okay, so 2 out of the 4 answers, so not that one. How about 3/10? That's 0.3. That's a 4. That's a 2. 4/5, not it. 4/10 is not it. That's 2/5. We already went over that one. 6, 3. What about 6/5? 6 divided by, let's see, 6 divided by 5. 1.2, getting closer. But we're out on those. 6/10 we already wrote down, so we know it's that one. 12. 12 divided by 2 is 6. 12 divided by 5. 12 divided by 5 is 2.4. And let's see, 12 divided by 10 is 1.2. So how are they rounding those bad boys, huh? How are we going to figure out those things? Because none of those guys added up to what we needed them to be. Now, if they're rounding, that's kind of a problem when we do that fraction, but they shouldn't be. So what's our combination that we're missing, right? Well, here's what we can do. Take the ones that we know, and we're going to use it to divide the equation down. So we know a 1/2. So -1/2. We're going to put it in the half box. We're going to take our original 10, -11, -42, +7, and 12, right? So x equals -1/2, 3/5. We need 2 more. And we're going to synthetically divide this equation. Let's see, 4, 3, 2, 1, 0. Yep, everybody's there. Always check. So drop the 10. -1/2 times 10 is -5. -11 and -5 is -16. Negative makes positive. Half of 16 is 8. -42 and 8 is going to be negative. Drop that, 34. -1/2 times -34 is going to be positive 17. 17 and 7 is going to be 24. -1/2 times 24 is -12, and we get a 0. Now we're going to take those same exact ones, and we're going to use our 3/5. 10, -16, -34, 24. And we're going to break that down one more time. We get 10. 3/5 times 10. 5 goes into 10 twice. 3 times 2 is 6. -16 and 6 is -10. That's going to be -6. That's going to be -40. 3/5 times -40 is going to be negative. 5 goes into 40 8 times. So 8 times 3 is 24, and we get a 0. And we've got 10. This is x. That's x squared. We've got 10x squared minus 10x minus 40 equals 0. And we get the quadratic that we can work with now. I'm going to divide off the 10 from everybody. Gives me x squared minus x minus 4. And we're going to say, let's see, x factors of 4 that subtract a 1. Are there factors of 4 that subtract a 1? No, there are not. Factors of 4 do not subtract a 1. So we're going to have to use the old quadratic formula. Yeah, good. Big eraser for big problems here. This is why we did all of that quadratic stuff. So we got negative plus or minus. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. My b is a -1. My a is a 1. My c is a -4. So 1 plus or minus the square root of 1 Negative 4 times 1 is negative 4 times negative 4 is plus 16 over 2, which is 1 plus or minus the square root of 17 over 2. That's my other answer. 1 plus or minus the square root of 17 over 2. Now, the thing with listing all of those out is that list is only the list of the possible rational. It's not all of them. That's why we had to get to this guy. You can check them all, see if they all are, but the irrational ones aren't going to pop up in that rational root theorem. The whole point is this is irrational. And when we go back, look, it says rational root theorem. It only gives you the rational roots. So you're going to have to do something to get the irrational parts. This is where the big work of this chapter comes in. We're putting everything together now. So find all the real solutions of x to the third minus 5x squared minus 2x plus 24 equals 0. And then find all the real zeros. This word, that word, same thing. The reason it's differently worded is because f of x is the function part, 0 is what it's equal to. So we're just substituting this in there, finding zeros. So let's look at the first one, which is x to the third minus 5x squared minus 2x plus 24. Now, if you look at the graph, and we got the right one, x to the third minus 5x squared minus 2x plus 24. We should have, where'd I go? We should have 3 solutions. And notice where the wiggle is up here. It's way up high. It's not going through the x-axis. So it only actually goes through in one spot. The rest of the spots aren't a place where it goes through. Those are an imaginary spot. So we have to find that rational piece there. Okay, negative 3.678, most likely going to be an irrational spot. We don't want it to be quite like that. I wish I could. So we want to be able to find that piece. 0 doesn't work. 1 doesn't work. Let's see, make sure my graph's right. Oh, even better. Daha! That wasn't going to work out because there wasn't a way to find that without dividing some off. So just make sure you type it in good. X to the third minus 5x squared minus 2x plus 24. Now it's better. Boom, boom, boom. Oh, like it when it goes like that because x equals negative 2, 3, and 4. Found them. We needed 3. We got 3. There you go. Downfall of doing the type in and not doing the work is if you type it wrong, you don't get an answer that you can look at nicely. All right, let's try this other one. 3x to the fourth minus 2x to the third minus 37x squared plus 24x plus 12. We should get 4 solutions. X equals 1, 2, 3, 4 things. 1, 2, 3, and 4. 2 of them, if you'll notice, are same number, different signs. So that's a plus or minus situation. It's 3 decimal places. Those are going to be my irrationals. So I'm going to have to use these other ones. Now, the 0.333, even though it's 3 things, and I'm thinking, oh, then maybe that's rounded up in irrational, 0.3333 is actually a fraction. It's negative 1/3. The other one is at 1. And so we know 2 of these so far. We just need the other 2. So we got to break that equation down into its quadratic piece that we can deal with. Because 1, 2, 3, 4, 5 terms, we can't do factor by grouping. We can't do quadratic form. So I'm gonna do 1 first. Hopefully that one works out nicely. try to save the fraction for something that has all 3 stuff in it. So we've got 3, negative 2, negative 37, let's see, 4, 3, 2, 1, 0. Everybody's there. 24 and 12. Separate, drop. 1 times 3 is 3. Negative 2 and 3 is 1. 1 times 1 is 1. Negative 37 and 1 is negative 36. 1 and negative 36 is negative 36. 24 and negative 36 is negative 12. 1 and negative 12 is negative 12. And we get a 0. Voila, it works. Now these all have 3, 36, 12 have factors of 3 in them, and 1 times a 1/3 is easy. It's a 1/3, so that will be nice. Now all we got to do is do one more. 3, 1, negative 36, negative 12. Drop the 3, and we're doing a negative 1/3. Negative 1/3 times 3 is negative 1. Negative 1 and negative 1 is 0. Anything times 0 is 0. Negative 36 drops that way. Negative and negative makes positive. 1/3 of 36, or 36 divided by 3 is 12, and we get a 0. So that's my x squared. Most likely it's not a quadratic formula if it's the same number, top and bottom. So we're going to work with 3x squared minus 36 equals 0. We could do this in the quadratic formula. My b would be a 0, but really, because all I have is the squared term, I don't have an x linear term, I'm just going to add 36 to both sides. 3x squared equals 36, and we're going to divide by 3, and x squared equals 36 divided by 3, and then we're going to square root, and when we do that, we get plus or minus. Square root of 36 is 6, and the square root of 3 on the bottom, which you can't do, so we multiply by the square root of 3 top and bottom, rationalize the denominator, so we get 6 square roots of 3 over 3, plus or minus. So 6 square roots of 3 over 3, and negative 6 square roots of 3 over 3. That's the plus or minus part. We get all 4 answers. When it's got that irrational piece to it, it's got some work that you got to do. Last little part we're going to talk about is the irrational conjugates theorem. In example 4, notice the irrational zeros are conjugates of the form a plus b, a plus the square root of b, and a minus the square root of b. Okay? So when you have radicals as part of your solution, solves, answers, x's, intercepts, factors, you have to have positive and negative. So if they're saying that, like they are right down here, write a polynomial function of least degree that has rational coefficients and a leading coefficient of 1. So they're just saying write an equation, and they're giving you info. The zeros are 3 and 2 plus the square root of 5. So if we draw it on a graph, they're going to hit at 3, and it hits at 2 plus whatever the square root of 5 is. So let's look at it in decimals. What's 2 plus square root 5? About 4.236. So 3.236 is about there. But what they're saying is, if you have the 2 plus square root of 5, you've also got to have the 2 minus square root of 5. 2 minus square root of 5, which is going to be negative 0.236. Notice that the decimal places are the same. It's just that front ones number that's different. So that's going to be a spot that's about here. 1, 2, 3 spots. It's got to have 3 spots because you got to have 2 of these and 1 of those, which means it's going to be a degree of 3. That's the lowest it could be. So they want us to write the polynomial that gives you these 3 answers. That means we have to create factors and multiply them together. This gets a little weird, but stick with me. Opposite to get in. X plus, actually, we're going to do minus. X minus 2 square root, 2 plus the square root of 5, and x plus, nope, actually it's going to be minus again. Hello. Minus 2 minus the square root of 5. Okay, see those differences. I'm going to multiply the radical ones together first. Because they're conjugates, it's going to get rid of the radical part. So I'm going to do it in a box. I've got x, I've got minus 2 square root, no, minus 2 minus the square root of 5. Everybody times everybody. 3 different terms. We need another box. And minus the square root of 5. And we need another box this way. Minus 2 plus square root of 5. Okay? Because I'm treating, and I'll show you in different parentheses, this whole thing just like I did the 3. Right? So it's always x minus k, x minus that factor number, that x equals number. So I plugged in the 3, that's why it changed signs. I plugged in the 2 plus the square root of 5, and I plugged in the 2 minus the square root of 5. You can deliver it to both. It's not going to change it much. Okay? You're going to get x minus 2 plus the square root of 5 and x minus 2 minus the square root of 5. So in the first box, you get x squared. And you get negative 2x. And then you get negative x square roots of 5. And then you get negative 2x. And then you get positive 4. And then you get positive 2 square roots of 5. And you get positive x square roots of 5. And then you get negative 2 square roots of 5. And then you get negative square root of 5 squared. A square root squared is the number underneath. Diagonals are your coefficients. This one doesn't have a diagonal, so we've got x squared. These guys are diagonal. They're like terms. Sorry, diagonals are your like terms, not your coefficients. Negative 2x and negative 2x is negative 4x. These guys, kind of like terms. Really, it's these guys, but one's plus and one's minus, so they go out, and you got a 4. These guys are like terms. One's plus, one's minus. They cancel out, and we got a minus 5 on there. So to sum up, we got x squared minus 4x minus 1. That's our polynomial that we need so far, right? It's not my answer one. I think I circled that a little prematurely. X squared minus 4x minus 1. That was just these two multiplied together. Don't forget, with that graph, we still have to multiply x minus 3 times x squared minus 4x minus 1. I can hear it at home. But x times x squared, x to the third. So I'm not doing the box method this time because I don't need it to be all that clean and together. X times negative 4x, negative 4x squared. X times 1, negative x. Negative 3 times x squared, negative 3x squared. Negative 3 times negative 4x. Oh, that was supposed to be negative 4x squared. There we go. Negative 3 times negative 4x is positive 12x. And negative 3 times a negative 1 is a positive 3. That's got 2, that's got 2, that's got 1, that's got 1. X to the third minus 7x squared plus 11x plus 3 gets us those factors. And we can always check it. We can say x to the third minus 7x plus 11x. That's supposed to be x squared plus 3. Boom, boom, boom. There's my 3. There's my 4.236 like we needed. There's my negative 0.236 like we needed when we did this 2 plus the square root of 5 and 2 minus the square root of 5. So yes, it works. Man, that's a monster. So we had a polynomial function of the least degree that has rational coefficients and a leading coefficient 1. Same story as last time. Here's my zeros. 4 and 1 minus the square root of 5. So that means I'm going to do x minus 4, x minus 1 minus the square root of 5, and x minus 1 plus the square root of 5. Which really you can take those little parentheses off inside there and leave them just like they are, because you distribute the negative, the 1 goes negative, the square root of 5 goes positive, the 1 goes negative, the square root of 5 goes negative. I would do the box. You're going to need a 3 by 3 because it's got 3 terms. I do this one and that one first. X, -1, negative square root of 5. X, -1, positive square root of 5. I've got you set up to get started. So take a pause right here, finish out the box, get that quadratic, multiply it times that x minus 4, get your answer at the end. Come back and check. Okay, here we go. X times x is x squared. X times -1 is negative x. And you got negative x squared to 5. You got negative x. You got positive 1. You got positive square roots of 5. You got x square roots of 5. That's positive. You've got negative square roots of 5. And you've got negative 5. These guys cancel out. These guys cancel out. They will always cancel out. Like terms. Like terms. So you're going to do x minus 4 times x squared minus 2x minus 4. If you want to do the box on this one again, box it again. I'm going to do linear. That's x to the third, negative 2x squared, negative 4x, negative 4x squared, positive 8x, positive 16, single, double, x to the third, negative 2x squared, negative 4x, negative 6x squared, 4x, and 16. And just in case, let's check. X to the third minus 6x squared plus 4x plus 16. 4, and those are my decimal places. Let's check my decimal places. What's 1 minus the square root of 5? 1.23, negative 1.236. Bam, got it. And that's what it takes. Those irrational answers are going to be the ones that you struggle with. You're going to either have to use the rational ones you can find on the graph or through the rational root theorem to divide down into a quadratic you can solve. And then these you got to build back together. And I would get rid of the radical parts first. Good luck.